Moving average models. So friends, what is a moving average? Let's understand that. Let's say a company has 10 years of revenue numbers. The revenue numbers go like this: 200 million, 250 million, 210 million, 195 million, 220 million, 180 million, 210 million again, 235 million, 260 million, 280 million. So these are the numbers from 1 till the 10th years. Now I decide that I need a 5-year average of these numbers. So 5-year average means what? I take 5 consecutive numbers, let's say these 5 consecutive numbers, and take their average. And that becomes my moving average number, right? So how will I do that? So I'm looking at 5-year moving average, right? So what will be the current value? That is the 10th year value. The 10th year value will be the last 5 values, 180, 210, 235, 260, 280 added and then averaged. So this will come like this: 180 plus 210 plus 235 plus 260 plus 280 divided by 5. This is the year 10 5-year moving average value. So let's calculate it, friends. The value comes to be 233. Okay. So this is the value for year 10 5-year moving average. Similarly, for year 9, the 5-year moving average will be 220, 180, 210, 235, 260. These 5 numbers added and then averaged. That is divided by 5. So these numbers will be 220, 180, 210, 235, 260 divided by 5. The value will come to be, let's calculate, friends, 221. In the similar way, we can get the values for year 8, year 7, year 6, year 5, right? So let me calculate the values. You also calculate and verify whether the values are coming or not. So year 8 will be 195, 220, 180, 210, 235. 195 plus 220 plus 180 plus 210 plus 235 divided by 5. So the value is coming to be 208. For year 7, let me change the color once again: 210, 195, 220, 180, 210. So like this you get the point, guys, how we are going to do year 6 and year 5, right? So year 6 will be 250 plus 210 plus 195 plus 220 plus 180. This is equal to, this divided by 5 is equal to 211. And the last value, again let me change the color: 200 plus 250 plus 210 plus 195 plus 220 divided by 5. This is 215. So friends, beyond year 5 we cannot go. We have calculated these, right? But here we cannot go. Year 4 5-year moving average is difficult to calculate because what? We do not know what is the value of this year. Year 0 value we do not know, right? So we cannot calculate. But we can calculate from year 5 onwards because we have all the 5 values. So this is how a moving average works. So if we generalize the equation, moving average of 5 values taken together comes to be like this: xt is equal to xt plus xt minus 1 plus xt minus 2 plus ... xt minus n divided by n plus 1. Or you can write xt is equal to xt plus xt minus 1 plus xt minus 2 plus dot dot xt minus n minus 1 divided by n. These both equations are valid for a moving average, right friends? Now friends, our calculation looked at historical calculations, right? Historical numbers. We knew the numbers and we calculated it. Now in case we need to project it, we have to get into a more mathematical format. Let's look at that. So, projecting with the help of moving averages. Projecting with the help of moving averages. How do we do that, friends? Let's say we are looking at a first order moving average, MA1. So what do we mean by first order moving average? First order moving average means xt is a function of a random variable at time t and a random variable at time t minus 1. That's it. Nothing else. And a second order moving average means MA2 means xt is dependent on, or xt is a function of a random variable at time t, a random variable at time t minus 1 and a random variable at time t minus 2. Now these et and et minus 1, this can be equally weighed or differently weighed. If they are differently weighed, the equation becomes like this. Xt is equal to et plus theta multiplied by et minus 1, where theta is not equal to 1. Because we are given et a weight of 1, we are giving a different weight to et minus 1, which is theta, and it is not equal to 1. So it is a differently weighed equation that we are trying to create through this. And this is the generalized equation for MA1, that is first order moving average. Now we'll look at a few properties of this equation, friends. So friends, this is our moving average first order equation, and the properties that we already know are et is a random variable, theta is not equal to 1. Now a few other properties are the expected value of this random variable is 0. The expected value of this random variable is 0. Okay. Then the variance, the expected variance of this random variable is, let's say, sigma square. The covariance, expected covariance of this random variable with respect to some other random variable which is lagged, this is equal to 0. T is not equal to S. So these are the properties that this equation has. Now friends, how do we detect whether an equation is a moving average or a autoregressive kind of an equation? How do we understand that? Let's say you are given an equation xt is equal to b0 plus b1 xt minus 1. Let's say you are given this equation, and the question is detect whether this is an AR1 model or MA1 model. How would you detect that, friends? The detection is pretty simple. If you understand, if you know the information, the detection becomes very simple. You do a t-statistic test. First, do one thing. Regress this xt with all the orders of xt minus p, generalize p. So what I am meaning is, regress xt with respect to xt minus 1, then again regress xt with respect to xt minus 2, xt minus 3, xt minus 4, dot dot dot. You do it for any number of lags that you want, and you find out the t-statistics of b1. T-statistic of b1. b1 means this one. This one means you just replace this xt minus 1 with xt minus 2, then you replace it with xt minus 3, You just do that. Okay. And you find out the t values. Let's say the values come to be t1, t2, t3, t4, dot dot dot. If the model is an AR1 model, then the first value will be significant. Then the values will go down gradually. So let's say the first t1 value will be, if I plot it, these are the t values. The first t1 value will be somewhere here. Then it will move down gradually, like this, for example. Right? This is t1, t2, t3. Like this, the movement will happen if it's a AR1 model. And if it's a MA1 model, it will be different, friends. If it's an MA1 model, what will happen is the first value, that is the t1, will be significant. And then there will be a sudden drop, not a gradual drop, friends. It will be a sudden drop. So the graph may look something like this. So the first value comes here, and then the other values go like this. So this is t1, and this is t2, t3, etc. So this is the difference. AR model will show a gradual drop. MA1 model will show a sudden drop. This is very important, friends. Gradual drop for AR1 model and sudden drop for MA1 model. So this is the difference that can help you understand whether it's a AR model or a MA1 model. Now friends, we'll talk about a phenomenon called seasonality.